Good morning, guys. Today we are going to discuss about IPv4 addressing and subnetting. Now, before we jump into IPv4 addressing, just as a side note, this is IPv4. When we say it is a version 4 of IP addressing, there is one another system called IPv6 or IP version 6 that we will be studying in future classes. But for today, we are going to focus on IPv4 addressing. Now, IPv4 addressing is a 32-bit addressing system. So its 32 binary digits are involved in the IPv4 addressing. Now, if you know binary digits, you must be knowing that with 32 bits you can create that there will be 2 to the power 32 possible combinations. So it will be something in the range of 4294967296. So it's something in the range of 4.3 billion. Now that is the total number of IPv4 addresses possible. So you don't need to remember these numbers, but just to give you an idea, means an estimate, the total number of IP addresses that is possible is something in the range of 4.3 billion. Next, the IPv4 address is a logical address. What is the meaning of a logical address? A logical address is something that could be changed. It's not permanent. It could change. Just to give you an idea. So suppose you are sitting in a city, and if you change your city, your IP address will change. Suppose if you are moving from city 1 to city 2, or if you are moving from one country to another country, your IP address will change. The contrary to this logical address is something called physical address. So one such example of physical address is the MAC address, or media access control address. The MAC address of your laptop or desktop is called the physical address. Why it's physical address? Because it doesn't change. The MAC address of your system doesn't change. So if you change the network interface card of your system, then definitely the MAC address will change, because the MAC address is actually the address of your network interface card. So if you change the network interface card of your system, the MAC address will change. Otherwise, the MAC address of your system remains the same. Doesn't matter in which country you are. And the IP address is actually allocated by an organization by the name of INA. It stands for Internet Assigned Numbers Authority. So INA is an organization that is responsible for the allocation of IP address. Now IP addresses are divided into 4 octets. So when we say octet, it represents the number 8. So IP address is divided into 4 different octets. So octet would be something it's like one. If I just give you an idea of one octet, it is something like 101001110. So there are 8 binary digits in one octet. Similarly, there would be four octets that makes up the 32-bit IP address. So this is the first octet. Then there would be dot, then second octet there would be dot, third octet there would be dot, and fourth octet. So that 8 bits in one octet, 8 bits in second octet, 8 bit in third octet, and 8 bit in fourth octet. So combined it is 32 bits in IPv4 address. Now IPv4 address is represented, it's called dotted decimal notation. So what is the meaning of dotted decimal? So even though the IPv4 address is understood by computer in the form of a binary digits or 1 zeros, a combination of ones and zeros, we as a human being find it easier to remember or to use in the form of binary digits. So something in the form of decimal numbers. So you can see a decimal number 2 followed by dot, decimal number followed by dot. So that's why it's a dotted decimal notation. So that's what we use in order to deal with the IP addresses. But the computers deal with IP address in binary notation. Now IP address is divided into 2 parts: network portion and host portion, that we are going to discuss in future slides. Now the IP addresses that approximately 4.3 billion IP addresses are divided into 5 different classes. So before we understand the class, just remember that the class of any IP address is determined only by the first octet. The first octet of an IP address determines class. You don't have to look at the second, third and fourth octet in order to identify the class. The first octet itself will tell you which class this IP address belongs. So if the number is between 0 to 127, that is class A IP address. Okay. If the number is between 128 to 191, that is a class B IP address. If the number is between 192 to 223, that is a class C IP address. If the number is between 224 to 239, that is a class D IP address. And if the number is between 240 and 255, that is a class E IP address. So this is in the form of a decimal notation. So if the IP addresses are given in the form of a decimal notation, you just have to look at the first octet and you need to remember the range. If the number falls between 0 and 127, that is a class A. Similarly, you need to remember all the different ranges. But suppose if you are given the IP addresses in the form of a binary digits, and if it is taking time for you to calculate, if it is taking time for you to calculate the what would be its value in decimal, then this is a simple way of remembering it. If the first binary digit is 0, if the first binary digit of first octet, remember, in order to identify the class of an IP address, you just have to look at the first octet. You don't have to look at second, third and fourth octet. It is the first octet that tells the class of an IP address. So if the first bit of first octet is 0, it doesn't matter what the second, third, fourth and remaining octets. If the first bit of first octet is 0, that is a class A IP address. If the first two bits are 1 and 0, it is class B IP address. Similarly, for class C, it has to be 110, class D 1110 and class E 4 ones. It doesn't matter what the remaining 4 bits are. It could be all ones, it could be all zeros, or a combination of ones and zeros. But you need to remember these binary digits in order to identify the class of an IP address. Similarly, there are some other special IP addresses. So there is something called there is something special IP address called loopback IP address. It is the 127 range. If an IP address starts with 127, it doesn't matter what is the second octet, third octet and fourth octet. If the IP address starts with 127, that's called loopback IP address. Basically, this IP address is used to check the TCP/IP protocol suite of your machine. It's basically used as a troubleshooting tool, first troubleshooting tool to check whether your machine is working properly or not. So 127 range is dedicated for the loopback testing. There is one another range called 169.254, and this is called APIPA. APIPA. So what APIPA stands for? Automatic Private IP Addressing. So APIPA is Automatic Private IP Addressing. So that is APIPA. So what is this 169.254 APIPA IP address? So suppose your computer is trying to get an IP address from a DHCP server. So DHCP is something that you will study in your CCNA. But suppose if your computer is trying to assign IP address from a DHCP server, and for some reason it's not able to get an IP address. So your computer or basically the Microsoft OS assigns an IP address to its own machine in this range, that is 169.254. So basically, whenever you are seeing an IP address of your machine as 169.254, just understand that this is not a good situation, and you need to troubleshoot why your computer is not getting IP address from the DHCP. This is not a good indication whenever you are seeing this particular IP address range. Now, like we mentioned, that IP addresses are divided into two portions: network and host portions. So And basically there are these three IP addresses, these three classes of IP addresses are the one that you need to focus on, for the purpose of CCNA. Class D is something that is used for multicasting purpose. That is that we don't assign to our systems, but it is used by some specific routing protocols and switching protocols as their addressing mechanism. And class E is used for experimental purpose, and class E is never been used, and it will never be used in future, because there is already a replacement in the form of IPv6 address. So these two classes, class D and class E, that you don't need to focus too much. Class D is basically, you just need to remember the range of class D and class E. Other than that, as far as subnetting is concerned, you are not going to get any subnetting questions on class D and class E. You just need to focus on the first three classes, class A, class B and class C. Now for class A, class B and class C, the default, the default way how they are represented is first there will be a network followed by host, host and host. So in case of a class A IP address, the first octet is the network portion and the remaining 3 octet is the host portion. For class B, the first and second octet are the network portion and third and fourth octet are the host portion. And similarly for class C, the first 3 octet are the network portion and the last octet is the host portion. Okay, this is the default behavior in class A, class B and class C. Okay, now let's move on. So to give you an analogy about the network and host portion. So suppose you are living in you have your house in one particular street, and you may have multiple neighbors in that street. Okay, so suppose the name of the street is, let's say, St. Mary Street. So the name of the street is St. Mary Street, and this is your house with house number of 10, your neighbor's house maybe 11, 12 or 13. Okay, so all the 4 houses, they have a common address, that's St. Mary Street, but their house numbers are different, like 10, 11, 12 and 13. Similarly, in case of IP address, all the machines in a particular network, their network portion would be same. So here you are seeing 3 machines, part of LAN 1, their network portion is 7 zeros followed by 1. All the 3 machines have the same network portion. Just like all the houses in a particular street, their street name or street number is same. Similarly, all the machines in a particular network will have the same network address, or network portion would be same, but their host portion would be different, just like the house numbers. So here you are seeing the host portion is 1. The last bit of last octet is 1. Here it is 10, here it is 11. Similarly, for LAN 2, you can see all 3 machines, their network portion is 10. Okay, the network portion is 10. So, and from the last slide, we know that this is network portion, this is host portion, this is host portion, this is host portion. So it is basically a class A IP address, because if we go back, class A, in case of a class A IP address, the first octet is the network and the last 3 octet are host. Okay, so here you can see that the first octet is the network and the last 3 octets are the host. So this is the class A IP address. This is how you can identify. And there is one another way that I mentioned earlier. If the first bit of first octet is 0, if the first bit of first octet is 0, that is class A IP address. You don't have to look into any other bits or any other octets. If the first bit of first octet is 0, that is class A IP address. Now let's go through some of the quiz. Here it says identify which of the IP address below belongs to class B IP address. So we know that in case of a class B IP address, the range is 128 to 191, and in terms of a binary it is 1 and 0, and the remaining 6 bits could be anything. So if in binary the number starts with 1 and 0, that is a class B IP address. So here we are saying this is the option C is the correct option here, because the number starts with 1 and 0. And if in terms of a decimal, if the number is between 128 to 191, it is class B IP address. So 191 falls in that range. Again, remember, whenever we have to find the class of an IP address, you just have to look at the first octet, not the second, third or fourth octet. You just have to look at the first octet in order to identify the class of an IP address. So this is also a right option. So 126 is class A, 194 is class C, and here this is from the first bit is 0, so it is class A. 110, it is class C. So the correct options are C and D, because 10 is class B and 128 to 191 range is class B. So C and D are the correct options. Similarly here, the next question is, which of the following IP address belongs to class C? So for class C, we know the range is between 192 to 223, and in terms of a binary it is 110, and the remaining 5 bits could be anything. So 110 is option B, and yeah, in binaries this is the only option, and in decimal 192 to 223 to 223 is this one. In this range only option E falls. So B and E are the correct answers. Now the IP addresses could be of it could be of two types. One is called public IP address and another one is called private IP address. What is public IP address and what is private IP address? So public IP address is something that is given to you by an ISPs. An internet service provider give you the public IP address, and as far as private IP addresses are concerned, you don't have to go to any organization to get the private IP address. You can use whenever and wherever you want. The only difference between public and private IP address is that public IP address are routable. So what is the meaning of routable? Routable means if two machines, suppose one machine is sitting in city A and the other machine is a part of city B, and if they need to communicate, and suppose these two machines are situated thousands of miles from each other, if these two machines need to communicate with each other, the communication will only happen with the help of a public IP address. And the public IP address is something that is routable, means the packet can flow with the help of public IP addresses. But if we are using private IP address, they are non-routable. Means if you are using a non-routable private IP address, then two machines which are connected through internet, that they cannot communicate with the help of private IP addresses. But if you are sitting in a local network, if you are part of a local network sitting in the same office, same building, and if you want to communicate with each other, you can communicate. You can easily communicate. You don't have to go to ISP and you don't have to purchase any IP addresses. Private IP addresses are sufficient for communication within a local area network, but they are not enough if two machines are connected through internet and they need to talk to each other. Now there is something called RFCs. Request for comment. You can study about RFCs. There are different RFCs for different protocols and different standards. So there is one that is specific RFC called 1918 that is reserved for private IP addresses. And like I mentioned, private IP addresses are basically used for internal purpose only. Like two machines in the same local network want to talk to each other. And these are the range of private IP addresses. So whenever you are seeing IP addresses from this range, just understand that they are private IP addresses, and these IP addresses, with the help of these IP addresses, two machines cannot transmit the packets over the internet. But yeah, they can easily talk to each other in a local private network. You need to remember these ranges, by the way. Now, as far as public IP addresses are concerned, public IP addresses are globally unique IP addresses. Globally unique means if I have a public IP address, let's say in the range of 3.3.3.3.3, no one in the entire internet can have this public IP addresses, because the public IP address has to be unique. Two machines sitting on the internet, they cannot have the same public IP address. And public IP address it has to be purchased through your ISPs, and which the ISPs in turn will get it from something called RIR, that is Regional Internet Registries. There are 5 different RIRs, or Regional Internet Registries. You don't have to go into much detail, but there is a hierarchy of different organizations that assigns IP address to one another. So RIRs gives ISP address to ISPs, and we as a customer get IP address from the ISPs. The public IP addresses has to be purchased from the ISPs, and they are usually used in Internet Edge. Internet Edge, basically, to simplify it, you basically need public IP address in order to communicate over the internet. And like I mentioned, these are the 3 different classes that you need to focus on. Class A, Class B, and Class C. Whenever we are talking about the communication, communication between two computers, whether it is within your network or outside your network over the internet. Now, the range. What is the range of public IP addresses? All the IP addresses apart from this RFC 1918 IP addresses, they are all public IP addresses, with definitely few exceptions, like we already discussed, like 127 IP address, that is a loopback IP address, 169.254, that is also a PIPA IP address, and similarly the network 0, it also cannot be used. So 0 network cannot be used. 127 is reserved for loopback. 169.254 reserved for PIPA. Other than that, there are also few exceptions, but basically these are the basic exceptions, and RFC 1918 IP address. So apart from this, all the other IP addresses are public IP addresses. Now, one important thing about IP address, there is something called Subnet Mask. Whenever you are given an IP address, let's say if I give you an IP address, let's say 10.10.10.10, and if I say which is the network portion of the IP address and which is the host portion. So like I mentioned earlier, you know that 10 is the class A IP address. 10 belongs to class A IP address. So it is network, host, host, host. So yeah, from if we just go ahead with this mechanism, it's so the first 10 is the network portion, and this is the host portion of the IP address. But down the line, this particular convention of using the first octet as the network and the remaining 3 octet as the host has changed. Now we use something called subnetting, where we break a major network into multiple smaller networks. So the concept of the class is vanished. Now we are in a world called classless. There is no concept of class. Everything is classless now. So if you are given an IP address, and if we say which is the network portion and which is the host portion in the classless world, it would be difficult for you to tell what is the network and what is the host portion. In order to simplify this, we use a different number along with the IP address that is called subnet mask. So basically, subnet mask is the number that is used to identify the network portion and host portion of an IP address. So suppose if you are given an IP address, let's say same IP address, let's get go for the same example. It's 10.10.10.10, and if there is a subnet mask, let's say 255.255.0.0, and if you are given this number and say, somebody asks what is the network portion and what is the host portion. Now, just like IP address is 32-bit in size, the subnet mask is also 32-bit in size. Okay. The bits in subnet mask which is on, so when I'm saying on, you must be knowing that how we get 255. It is a combination of 8 1 bit, right? So combination of 8 1 bit will give you 255. If the bits in the subnet mask is on, it means if it is 1, the corresponding bit in the IP address would be the network portion. So here in this example, 10.10.10.10, and the subnet mask is 255.255.0.0, the first 16 bit, it is 8 and it is 8, because here it's 255, it is 255. So the first 16 bit is network portion, remaining 16 bit is host portion. So if your IP address is 10.10.10.10, it means the first 210 are the network portion and the remaining 210 are the host portion. So this would be the network portion and this would be the host portion. Okay, so basically subnet mask is a binary number, or a decimal number that is used along with the IPv4 address just to identify what is the network portion of the IP address and what is the host portion of the IP address. Now subnet mask can be represented in different ways, just like IP address. You have your binary representations. It can be represented with a dotted decimal. And there is one another representation called shorthand or backslash notation, sometimes called slash notation. So here you can see there are 16 bits. 16 bits are on, right? 16 bits are on. And if you change that 16 bits in decimal format, that would be 255.255.0.0, because if you add this 8 bits together, it would be something like 127 plus 32 plus 127 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So if we add all those numbers together, it would be 255. So basically 255.255.0.0. So that is subnet mask in decimal notation. And since 16 bits are on, we can simply represent as a slash 16. That's the third way of representing subnet mask. So if you assign an IP address to a machine, the machine usually use the subnet mask in order to identify what is the network portion and what is the host portion. Now these are the 3 different formulas that you need to remember, and with the help of these 3 formulas, I believe you can solve almost all of the questions related to IP addressing and subnetting. So the first formula says 2 to the power Sn, or subnet bits, 2 to the power subnetting bits or subnet bits. So how many subnets you can create from an IP address is defined by this formula 2 to the power Sn. Okay, the second formula says 2 to the power h minus 2. So how many hosts are available per subnet? So you need to identify the host bits, how many host bits are available, and subtract 2 from that value. And the third thing is called the block size. How you can find the block size. So we are going to discuss about all those things in the following quiz. So the block size is basically 256 minus the last non-zero octet of subnet mask in decimal. So if you are given a subnet mask, let's say 255.255.0.0, in that case the block size would be 256 minus last non-zero octet. So last non-zero octet is this one, non-zero octet of subnet mask in decimal. Yeah, so it is 255. 256 minus 255 is 1. So the increment, the different blocks or different increment would be in 1. So what I mean by that? So basically I mean that if the IP address is 10.10.0.0, the next network would be 10.11. Why 11? Because there has to be an increment of 1 in the second octet. Okay, in the second octet. So it has to be 10, 11, then 10, 11, then you will get 10, 12, 10, 13, 10, 14, something like that. So that is how you calculate the block size. Now with respect to the and identifying the total number of subnets and total number of hosts per subnet, let's go through some of the quizzes. So here let's it's already 30 minutes. Let's divide into another video.